We continue our analysis of far-infrared heating for this winter. The current graph shows the different energy sources used over this heating season, with a nice peak in December correlating with the cold snap. This month has been much milder than December and warmer than January as well. As a consequence, we've seen a reduction in the energy needed for heating. In terms of stats, we've used a total of 469.27 kilowatt hours of electricity for heating in February, of which 177 kilowatt hours came from the battery, 154-ish came from off-peak electricity, and 98.5 came from peak electricity. A further 39.9 came from self-generated solar. This solar generation largely went into temperature boosting the property, so it isn't clear how much of this energy would have been consumed without the solar available. You may note that solar has decreased this month compared with last. Part of this will be due to other uses of the solar energy which will have taken energy away from heating, for example, washing machine usage in the daytime. The calculations have always been done assuming the worst case energy source for heating at any time. However, the more significant contributor to the reduction in solar comes from a failed panel in our array. You'll note one of the panels is much darker than the others and has generated no energy today. And if we look at the all-time generation, we see that panel has produced roughly 30 kilowatt hours less than each of the other panels. Technically, it doesn't appear to be an issue with the panel, but rather the optimizer connected to the panel. The optimizer helps to reduce the impact of shading on array performance, and despite the optimizers having a 25-year warranty, it appears they may not be as robust as we'd hoped. After all, the installation is only 6 months old. Currently, our installers Joju and the optimizer manufacturer SolarEdge are looking into whether it can be remotely resolved, and if not, someone will have to go onto the roof to replace it. Such is life. If you've had issues with optimizers failing, or you know others that have, then please let me know in the comments. It would be great to know how common an occurrence this is. Looking at carbon emissions, we find that 154.1 grams of CO2 equivalent per kilowatt hour were produced for every unit purchased from the grid, with emissions for heating being slightly lower at 141 grams of CO2 equivalent, this being due to the solar generation. It should be noted, while CO2 is being produced when this energy is generated, the amount of CO2 is much lower than it used to be and comparably better than other countries in Europe. Let's take the 3rd of February, where average emissions for the UK roughly matched our average emissions per kilowatt hour this month. We can see a range of different outcomes across Europe. Some countries like Germany and Poland have much higher emissions, which could give the impression of the UK doing quite well, and compared with 10 years ago, it's made significant progress. However, if we contrast these emissions with somewhere like Norway, which has abundant hydro and wind, well, then the UK is painted in the worst light. Emissions in the UK can be very variable. We rely on a quite varied energy mix, and renewables production can dramatically shift emissions per kilowatt hour. This contrasts with countries like France, which have consistent nuclear power ensuring fairly stable emissions. The graph on screen shows our household emissions per unit of electricity purchased against those of an average household in the UK. As you can see, we tend to manage slightly lower emissions through load shifting and the home storage battery. Putting this into context, we find that 66 kilograms of CO2 was produced in February to allow us to heat our home. If we'd been heating using gas in this month, we'd have contributed 136 kilograms of CO2 to the atmosphere. The eagle-eyed among you may have noticed that the gas emissions are over double the far-infrared emissions, yet our electricity emissions weren't half the gas boiler emissions. Well, this relates to the equivalent COP for the different energy sources. When we compare far-infrared to gas, we find that far-infrared has a COP of 2.29 for this month and 2-ish generally over the heating season. This means that for every kilowatt hour of electricity we'd need for far-infrared heating, we'd need roughly double that for gas. This has been calculated by forecasting the gas usage for each day over this heating period, based on the historical correlation between gas usage and outdoor temperature. I've described this process in more detail in the video looking at the December and January usage, link in the comment below. Generally, we've been happy with our move to far-infrared. There's definitely some scope for further improvements in efficiency, through better understanding the heat up times of panels and better controls through calculating heat loss for different rooms. And hopefully I'll get to play with some of these options in March and will update accordingly. Thank you for watching, and let me know if you have any questions, whether about the controls for the heating, how we've calculated our usage, or regarding renewables or home automation. It would be great to chat to you in the comments. Thanks for watching. Bye!